Hello everyone, hopefully you are doing well. So today we will start a new assembly using a famous mechanical mechanism which is rack and pinion. Please open my courses, go to lab number 7 and download the rack and pinion files. So in this uh, exercise, we're not needing any drawing. So please just only download the attached files, the gear, the rack, and the rack and pinion mates. After you downloading the three files, open the rack and pinion mate file. When you open the Solidworks rack and pinion mate file, you will see them are not attached to each other to create a mechanism. So we will create this mechanism. And we will create the visualization, which is very important, so we can analyze and see how these products will be assembled to each other. So we're gonna add multiple of mates. So start up with the first mate, go to the manager feature and select the mate. Now expand both the rack tree and the gear tree. Select the front plane for the rack, then select the front plane for the gear and make them coincident. Click on yes. Now we will add the second mate. So select the right plane for the rack and then select the right plane for the gear. And this time make them parallel. Click yes. So then click yes again. Now minimize the tree for the rack and the tree for the gear. So we want to make them kind of loosey. So we don't want them to be constrained. So please click Control and 1 and have the front view. Then select the mates. Go to parallel. So then select the surplus and you will see it's now on a gray. So these are not attached to each other. For old versions for Solid, so again go to Feature Manager, select the mate. So hover your mouse down until you see the mechanical mate, which is underneath the advanced mate. Selected. So it will give you a different options, cam or slot, hinge, gear, rack and pinion, screw, and universal joint. So please select the rack pinion. Now, just leave it in the minion pitch diameter. And now we want to select the mate selections. So for the rack, select the first edge. Then for the pinion, select the outer arc. Now click on yes. Hold and control and click 7 to have this ISO view and click on yes. So now you can move it around to see if the mechanism works by rolling the rack in front and back. Now we want to add the animation. So hover your mouse in the down. So we'll notice there is a model 3D and the motion study. Click on the motion study. So then you will notice there is a couple of options. One of them save animation, animation wizard, and there is a motor. So click on the motor. It will ask you if you have the type of motor. So for this one, we need the linear motion. Then here, it will ask you about the component direction. So select the bottom of your rack. So it will state which direction. Then it will ask you about the speed. So you can have constant speed, and you have also different expression for the speed. So keep it on the constant speed. Make it at 50 millimeter per second. So as you notice, in general, so we use an IBS metric, but for this exercise, we're using the ISO standard for the measurement. So you, in other example, for instance, you might using feet per second or inch per second. So click on here, yes. So now we will multiply this instead of 5x, please make it at 10. Now save it. Let's save it and play it again. So, so there is different options for the movement. So there is a playback mode normal, and there is playback loop, and there is a playback uh, reciprocate. Select the third one. Try to play it. See how it's look. So the motion should be more smooth, but because I'm using the live stream, so it's kind of delayed. After you selecting the third one over here and make it at 10 seconds, so you can save the file. The saved animation can be played using AVI, so you don't need to have the Solidworks. So you can show it to your manager, which probably didn't have the Solidworks. But for the submission, you need to go and click on Save As and save the file. Thank you, and see you in the